Good afternoon, dear friends. This is Dr. Harmesh Kansal, Professor and Head, Department of Mechanical Engineering, University Institute of Engineering and Technology, that is UIET, Punjab University, Chandigarh. Dear friends, the title of today's talk is Shear Force Diagram and Bending Moment Diagram. So, from this topic is concerned with strength of material subject or mechanics of solid subject. I think you are studying this topic in this semester. This belongs to SOM subject, SOM or MOS. Some colleges or some universities it is called mechanics of materials, MOM. Sometimes it is called MOM. So, we will talk about shear force diagram and bending moment diagram. How we can draw the shear force diagram and bending moment diagram. Before it, we should know what is shear force and what is bending moment. What is the concept of shear force and bending moment? Why we are drawing this? Why we are calculating the values of shear force and bending moment? What is its significance? What is the source of significance? We should understand it before actually knowing how to draw the shear force diagram and bending moment diagram. So, dear friends, I will talk to you on this whiteboard. Please make your attention, put your attention on this whiteboard. So, in this today's talk, we will study what is beam. After beam, what are the different types of beams? Beam, then types of beams, then load or force, types of loads, different types of loads. Then we will study in this class what is shear force. Then what is bending moment? Then there are certain conditions. Which should be satisfied for drawing the shear force or for calculating the shear force and bending moment. What are that conditions? Conditions for SFD and BMD. Then what is the general procedure to draw the shear force and bending moment? General procedure. Then what is the point of inflecture and point of contraflexure? Point of inflecture and point of contraflexure. Dear friends, these we will study in detail in today's class, that is on shear force diagram and bending moment diagram. Before this point number 7, conditions for SFD and BMD, we will also study sign conventions for drawing the SFD and BMDs. Where to take positive, where to take negative, upward is positive or downward is positive, left right is positive or right side is positive. That is called sign conventions. So, we will study, we should know about the sign conventions before drawing the shear force diagram and bending moment diagram. So, first of all, what is beam? So, dear friends, beam is nothing, it is a structural member. You all have seen the beam in your house, in the hostel room, in any building. That is a beam. Beam is a structural member. This is structural member. It has more length. Length is more than its diameter or width. For example, this is beam. On roof you can see this is beam, any roof, that is a beam which bear the load, that is a beam. This is a structural member, it is made from some material, that material may be the ferrous material, or maybe the ferrous material, or maybe the civil engineering material like concrete, cement, etc. It may be made up from wood also, it may be made up from the ferrous material also, steel, iron, etc. So this is structural member, this is called beam. We know already it, you have seen anywhere, any building, in a room, in your hostel room, in your house, what is a beam? So this is a beam. Now this is beam, it may be, if we see it from the side view, it may be rectangular. This beam may be rectangular from the side view, it may be triangular, or it may be circular, it may be square, it may be pentagon, it may be hexagon, any shape. So this beam may be like this, maybe this, maybe this, maybe this shape, maybe this shape. This is beam. This is beam. Clear? Now coming to types of beams. Second topic is different types of beams. So the types of beam may be number one is cantilever. My dear friends, you all know what is cantilever. Cantilever is this. Cantilever beam is that beam whose one end is fixed and other end is free. This is cantilever. One end is fixed and other end is free. On free end we can apply the load, or on the length of the beam we can apply the load. So we can apply the load here. We can apply the load here. This is cantilever. And second type of beam is simple or simply supported beam. How it is represented? It is represented that by this way, at its both ends, it is simply supported. In your house, in your hostel room, or in any building, generally we see this kind of beam. These are the two walls and this is beam. It is simply supported by the two walls at the ends. This is simply supported beam. So we can apply load here, we can apply load here, here, or maybe so many types of loads. So many types of loads are there. Here or here. This is called simply supported beam. And third is overhang beam. Overhang, as its name indicates, dear friends, as its name indicates, overhang. Overhang means this is beam, this may be overhang from one end, like this. This is overhang. So the length or the span of the beam is beyond the support, beyond the support. Support to bhi agge hai beam, the length. Or this is one side overhang. The overhang may be from both sides, like this. This is also overhang beam. So this is overhang one side, this is overhang on another side. This is overhang only on one side. Clear? And fourth kind of beam is fixed beam. Fixed. F-I-X-E-D. Fixed beam. That kind of beam, my dear friends, whose both ends are fixed. This is beam and this end is fixed, this end is also fixed. This kind of beam is called fixed beam. Clear? And there is another type of the beam that is called continuous beam. I will write here continuous beam. Continuous, as its name indicates, the beam is continuous, continuously supported. This beam is continuous, length is continuous, but supported only at one end. This beam is supported only at two ends. This beam is supportedly, but there is overhang. Overhang may be on one side, overhang may be on both sides. Here the two ends are totally fixed, hinged. This is called hinged beam or fixed beam. But in continuous beam, the beam is continuously supported, not by two supports but by a number of supports, like this, like this, like this, like this, like this, number of supports. This is continuous beam. Clear? So this is our second topic. This was, first is beam, second is type of beam. So here we discuss the different types of beams. One is cantilever, second is simple supported beam, third is overhang beam, and fourth is fixed beam, and fifth is continuous beam. Now dear friends, I am coming to the same topic, why we are studying the shear force and bending moment. Dear friend, there are different methods to represent anything. Now we are talking about shear force, so we can talk, there are different methods to represent the shear force and bending moment. One method is that we represent shear force and bending moment in the form of figure value. शेयर फोर्स और बेंडिंग मोमेंट ਨੂੰ ਕਿਸ ਤਰ੍ਹਾਂ ਰਿਪਰੈਜ਼ੈਂਟ ਕਰ ਸਕਦੇ ਹਾਂ, ਇੱਕ ਤਰੀਕਾ ਤਾਂ ਇਹ ਹੈ ਕਿ ਉਸ ਦੀ ਵੈਲਿਊ ਲਿਖ ਦਿਓ ਅੱਖਰਾਂ ਦੇ ਵਿੱਚ, ਵਰਡਸ ਦੇ ਵਿੱਚ. we can understand this is shear force value. Another way is to draw in the form of diagram ਕਿ ਕਿੰਨੀ ਵੈਲਿਊ ਹੈ, ਵੱਧ ਹੈ, ਘੱਟ ਹੈ, ਉੱਪਰ ਹੈ, ਨੀਚੇ ਹੈ, ਜਾਂ ਵੈਲਿਊ ਵੇਰੀ ਕਿਸ ਤਰ੍ਹਾਂ ਕਰ ਰਹੀ ਹੈ. this is another method. So instead of writing the value of the shear force and bending moment, it is much convenient as well as informative to draw the diagram to represent the shear force and bending moment properly and clearly and precisely. It is very important. Now you can see, what is this? This is load, this is force, load or force we are applying on this beam. When we apply this load here, what is the effect of this load? What is the effect of this load? What is the combined effect of these load on the beam? अगर मैं कैलकुलेट करके लिखूंगा तो ये लिख दूंगा, कोई वैल्यू आ जाएगी जी, इतने न्यूटन फोर्स लग रही है या किलो न्यूटन फोर्स लग रही है, लिख देंगे ना ਆਪਾਂ. लेकिन इस तरह नहीं ना पता लगता कि ਜਦੋਂ ਇੱਥੇ ਕਿੰਨੀ ਹੈ ਉਸ ਤੋਂ ਬਾਅਦ ਇਹ ਫੋਰਸ ਕਿਸ ਤਰ੍ਹਾਂ ਵੇਰੀ ਕਰ ਰਹੀ ਹੈ, ਉੱਪਰ ਨੂੰ ਵੇਰੀ ਕਰ ਰਹੀ ਹੈ ਜਾਂ ਨੀਚੇ ਨੂੰ ਵੇਰੀ ਕਰ ਰਹੀ ਹੈ, ਕਰ ਵੀ ਰਹੀ ਹੈ ਜਾਂ ਨਹੀਂ ਕਰ ਰਹੀ ਹੈ. It is very important to know it. Due to this reason, we are drawing the values of shear force and bending moment. Due to this reason, these are called shear force diagram and bending moment diagram, SFD and BMD. Clear? Now, why we are drawing this shear force and bending moment diagram? To know the deflection, to know the displacement in the beam due to the application of the different loads. Load may be one type or load may be different time. We will study later on what is load and what are the different types of load. We will study it. It is very important to understand what is load and what are the different types of loads. Clear? So to know कि हम कितना लोड लगाएं और क्या हो जाए उस लोड से, we should understand it. it is very very important for the designing of the beams कि अगर किस point, which point is weak point, which point is strong point, or overall beam is strong or weak, how we know it? There is only one methodology, there is only one technique or process, that is shear force diagram and bending moment diagram. So my dear friend, this is the reason why we are drawing shear force diagram, SFD and bending moment diagram, that is BMD. Now coming to first slide. So we have discussed what is beam, this is beam, different types of beams we have also discussed here, these are the different types of beams. Now we want to discuss what is load. Third point is what is load. So load, number 3. Load is also called force. The unit of load is Newton in SI system. The unit of load is called, unit of load is Newtons in SI system. It is called force. On beam, any beam, it may be cantilever beam, it may be simply supported beam, it may be overhang beam, it may be continuous beam or any beam. We apply force or load on it. Naturally we will apply because this is the application. अब हमने जे बीम, ये बीम आप बना के नहीं ना रखनी इदा रख दिए धरती ते, नो इनू आप यूज़ करने ना किते, जो यूज़ करांगे नैचुरली ये उपर कोई फोर्स लगेगी, उस फोर्स नू की कहंदे ने लोड, दैट फोर्स इज कॉल्ड लोड. जिस तरह जी छत पाने आ, छत की है रूफ, दैट इज ए रूफ, ऑन विच एक ही लोड लग रहा है किस दे उपर, बीम दे उपर. क्लियर. So we will discuss now. Fourth is different types of loads. Different types of loads. Number 1, point load, point or concentrated load. Point or concentrated load. So this is beam, this is beam. On this beam, say this is simply supported beam, this is A and this is end B, simply supported, दो support दी ही है ends के ऊपर, ठीक है ना. When we apply the load only at one point, pointed load or concentrated load, this is called pointed load or concentrated load, only at one point. This is one point. On this point we are applying the say W1 load here. On this point we are applying the another load W2 over here, only at one point, not at the whole length of the beam. This is called point load or concentrated load. And second is uniformly distributed load. Uniformly distributed load, and in short form it is called UDL. It is called UDL. So what is UDL? Say this is beam. On this beam the load is applied on the whole length or on a small portion of the beam. ये UDL है, सारी लेंथ दे उपर लग्या हो सकता है और थोड़ी लेंथ दे उपर भी लग्या हो सकता. इसनों असीं रिप्रैजेंट किस तरह करते हैं, बाय दिस वे. जिन्नी इंटेंसिटी इत्थे है, हुण देखो कंसनट्रेटेड और पॉइंट लोड दे विच की हो सकता है, W1 मे बी डिफरेंट फ्रॉम W2. इत्थे W1 दी वैल्यू है वो W2 तो वक्री हो सकती है, बट हेयर इन द केस ऑफ द UDL the value of the UDL may remained same, say W Newton per meter. मान लो ये 6 मीटर है लॉन्ग लेंथ और W कितने से 3 न्यूटन पर मीटर लग रहा है, ऊपर 3 न्यूटन पर मीटर, मतलब 1 मीटर दे विच 3 न्यूटन लग रहे हैं. 1 मीटर ਦੇ ਵਿੱਚ 3 ਨਿਊਟਨ ਲੱਗ ਰਿਹਾ ਹੈ ਤਾਂ ਟੋਟਲ ਕਿੰਨਾ ਲੱਗੇਗਾ 3 ਗੁਣਾ 6 18 मीटर, so it is 18 meters. 18 meter load is applying on the total length of 6 meter beam. 6 meter beam. Best example is roof of the building, roof of the room, roof. ਰੂਫ ਦੇ ਉੱਪਰ ਕੀ ਹੈ ਮਿੱਟੀ ਪਾਈ ਹੋਈ ਹੈ ਨਾ ਜਾਂ ਇੱਟਾਂ ਲੱਗੀਆਂ ਹੋਈਆਂ ਉਹ ਯੂਨੀਫਾਰਮਲੀ ਲੱਗੀਆਂ ਹੋਈਆਂ ਫਰਸ਼ ਲੱਗਿਆ ਹੋਇਆ ਜਿੰਨਾ ਇਸ ਐਂਡ ਦੇ ਉੱਪਰ ਲੋਡ ਲੱਗਿਆ ਹੋਇਆ ਉਨੇ ਹੀ ਸੈਂਟਰ ਦੇ ਵਿੱਚ ਉਨੇ ਹੀ ਇਸ ਐਂਡ ਦੇ ਉੱਪਰ ਉਨੇ ਹੀ ਇਸ ਐਂਡ ਦੇ ਉੱਪਰ this kind of load is called UDL, uniformly distributed load. ठीक है जी. And third is uniformly varying load. Uniformly varying load. Now here it is uniformly distributed. The total load is uniformly distributed. Here load is there which is uniform but not same value नहीं है, it is varying, it varies like this. Same, say this is beam, on this beam the load is represented like this. ये यूनीफॉर्मली वेरिंग लोड सारे बीम के उपर हो सकता है और ऑन द स्मॉल पार्ट ऑफ द बीम हो सकता है. सो दिस इज लोड एंड डिफरेंट टाइप्स ऑफ लोड्स. नाउ आई वांट टू शेयर वन इम्पॉर्टेंट पॉइंट ओवर देयर. ऑन ए बीम, say this is beam, say simple supported beam, there may be one type of load or combination of all these type of load are applied on a beam. In actual practice the loads are, in actual practice सच में जहाँ पे भी ये बीम लगी होगी तो वहाँ पे एक तरह का लोड ही नहीं होगा कि पॉइंट लोड लगा है, नो, या कंसनट्रेटेड लोड सॉरी यूनिफॉर्मली डिस्ट्रीब्यूट यूडीएल लगा है या यूवीएल लगा है, यूनिफॉर्मली वेरिंग लोड, नो, it is the combination, it may be single load or it may be the combination of all load. For example, say this is one load, point load, here may be the UDL, say 3 Newton per meter intensity. Next here may be the, from this point here may be the UVL, uniform varying load, like this. Over this time we have to draw the shear force and bending moment diagram for it कि वो इस लोड की वजह से इस बीम के ऊपर क्या असर हो रहा है, कैसे कैसे वो उसकी डिस्प्लेसमेंट या डिफ्लेक्शन वेरी कर रही है, कहाँ तक, कहाँ पे हमारा वीक पॉइंट है, कहाँ पे हमारा स्ट्रॉन्ग पॉइंट है, ये सारी इंफॉर्मेशन किस में मिलती है माय डियर फ्रेंड्स, दिस इज shear force and bending moment diagram से. Clear? So this is different types of loads. So we are coming here, we have discussed what is beam, we have also discussed the different types of beam, we have discussed the load and we have also discussed what are the different types of loads. This we have discussed. Now we are in a position to discuss what is shear force and what is bending moment. Number 5 and number 6, shear force and bending moment we can discuss now in detail. Shear force, SF, it is called SF. Say this is beam, say simple supported beam or cantilever. You can draw, you can take any beam, simple supported beam or cantilever beam. On this beam different loads are applied. What is the intensity, what is the desire of this load? ਜੇ ਇਹ ਲੋਡ ਦਾ ਕੰਮ ਕੀ ਹੋ ਸਕਦਾ ਹੈ? ਇਹ ਲੋਡ ਦਾ ਕੰਮ ਹੈ ਨੀਚੇ ਨੂੰ ਅਪਲਾਈ ਕਰਨੀ ਫੋਰਸ, ਤੇ ਸਪੋਰਟਸ ਦਾ ਕੀ ਕੰਮ ਹੈ? ਇਸ ਨੂੰ ਸਪੋਰਟ ਕਰਨਾ, ਕਾਊਂਟਰ ਕਰਨਾ, ਠੀਕ ਹੈ। ਤੇ ਸਪੋਰਟ ਸਾਡੀਆਂ ਇੰਨੀਆਂ ਅੱਛੀਆਂ ਹੋਣੀਆਂ ਚਾਹੀਦੀਆਂ, ਵੀ ਸ਼ੁੱਡ ਹੈਵ ਗੁੱਡ ਸਪੋਰਟ ਸੱਚ ਦੈਟ ਇਟ ਕੈਨ ਸਪੋਰਟ ਦਾ ਡਿਫਰੈਂਟ ਲੋਡਸ ਓਵਰ ਹੇਅਰ। When load is more than the support, the beam will crack, beam will destroy. This phenomenon is called shearing. Shearing means katna. Shearing means katna. And what is the intensity of that force which causes this shearing is called shear force. What is the value of force, that force which causes shearing, katna, is called shear force. Example is cutting of cloth, cutting with knife is the best examples of the shearing. So what will happen, say if this is beam, say if this is beam, so what will happen, the beam will shear like this, टूट जाएगी दो हिस्सों में, बीम टूट जाएगी ना दो हिस्सों ਦੇ ਵਿੱਚ। ਇਹ ਕੀ ਹੋਏਗਾ ਟੁੱਟਣਾ? ਸ਼ੀਅਰਿੰਗ। ਕਿਸ ਕਾਰਨ ਹੋਇਆ? ਫੋਰਸ ਕਾਰਨ। ਉਹ ਕਿਹੜੀ ਫੋਰਸ ਹੈ? ਸ਼ੀਅਰ ਫੋਰਸ ਹੈ। ਕਿੰਨੀ ਫੋਰਸ ਹੈ? ਐਨੀ ਫੋਰਸ ਹੈ। clear? This is shear force. Similarly bending moment. So to draw the shear force diagram, next is bending moment. Bending moment. Now due to this load, application of these load or one load or a combination of the different load, the tendency of the beam is to deflect like this. beam ਇਸ ਤਰ੍ਹਾਂ ਦੀ ਹੋਣ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰੇਗੀ, ਜੇਕਰ ਲੋਡ ਜ਼ਿਆਦਾ ਹੈ ਤਾਂ ਇਸ ਤਰ੍ਹਾਂ ਹੋਏਗਾ, ਜੇਕਰ ਹੋਰ ਜੋ ਲੋਡ ਜ਼ਿਆਦਾ ਹੈ ਤਾਂ ਟੁੱਟ ਜਾਏਗੀ। this will happen. clear? ਹੁਣ ਅਸੀਂ ਕਿੰਨਾ ਲੋਡ ਲਗਾਈਏ ਕਿ ਇਹ ਟੁੱਟੇ ਨਾ, ਸੇਫ ਰਹੇ? This is the question of the design. This is the duty of the mechanical engineer. This is the duty of the civil engineer. To know it. To know it, we are drawing the shear force diagram and bending moment diagrams. It will bend. It will bend. Now, what is the meaning of this moment? What is the meaning of this moment? Moment means घुमाना, घुमना या घुमाना, पंजाबी च घुमाना, कमाना. So the meaning of this movement is that either to twist or to rotate, either to twist. Moment it is a combination of the, or it is the multiplication of the force into distance, force into distance. This is movement. Mathematically this is movement. For example, this is beam. On this beam the load is applied here. If I put my finger here, what is the tendency of this load? It will try to rotate in this direction. It will try to rotate in this direction. So what is this tendency? So load is here, force कितने distance है? This is the distance, say x. So F into x. What is this? This is moment. This is called moment. और ये अगर बेंडिंग करने की कोशिश करे नीचे को, this is called bending moment. This is called bending moment. So we should also consider bending of the beams to know what is the result of this forces or these forces on the bending of the beam. This is determined by bending moment. This is determined by one term called bending moment. And when we draw how this bending moment varies This is